Oh, there we go. There's the bell. All right. Okay, all right. So there's the bell. All right. Go ahead and do the do now. So press pause. All right. It's gonna take you 5 minutes or so. Okay, because it's a long do now. So go ahead and do the do now, and then we'll get started. Okay. All right. And we're back. So let's see. How do we draw an acute equilateral? So I'm gonna use lines. Okay. I want to aim for I don't know what I want to aim for. I want to aim for perfection. Okay, all right. So sketch the following triangles, right? Acute equilateral. So acute means, right, all the angles are less than 90 degrees. So they're very sharp angles and all three sides are equal. So this is your, I really like this color. It's a fantastic color. So I'm aiming for this, okay? And to prove that this is an equilateral triangle, I am going to draw a slash on all three sides like that. Okay, the angles, nothing much you can do. I mean, you can do this, but it doesn't really. You can draw the three arcs inside, but that doesn't do anything either. Now, if you want to use numbers, that's perfectly fine. Meaning, you can do like 3, 3, 3 for the equilateral, and inside you could do like 60 degrees, 60 degrees, 60 degrees like that. That's up to you. Okay. The first way I did it is sufficient. Okay, what about the second one? Right scalene, so it's a right triangle. Scalene means all three sides are different. So something like this, perhaps. Okay, so the right angle is here. And then the three sides are different. How do you show that the three sides are different? Yeah, all three sides have different number of slashes, like that. And if you want to use numbers like 3, 4, 5, that's up to you. Okay. All right. What else? Obtuse isosceles. So obtuse isosceles. Obtuse means the angle is greater than 90, so it's kind of like a very wide angle. Isosceles means two of the sides are equal, so this one's tough. This is why I left this last. So the two sides have to be the same. So it can only be these two sides here. Okay, that's not a very good drawing, but it's close enough. Like that. Okay, meaning these two sides are equal. That means this one isn't, and this angle here, it's very wide. It's more than 90 degrees. So if you want to use numbers for that, like 3, 3, 5, and then like, I don't know, 120 degrees, something like that. That's up to you. Okay, so let's see. A few announcements today. So Unit 8, Day 13, homeworks on problematic. Quiz. What's today? Wednesday. So you're gonna get a quiz Friday. Okay, on wherever we stop Thursday. Okay, the emphasis will be on identifying triangles, like this sort of stuff. Okay, all right. Let's see. A few things here. Oh, yeah. So I emailed the grades to your parents yesterday. All right. So some of you right now and some of your parents are emailing me to see what homeworks you missed. Do me a favor. When you finish your homework, however many homeworks you missed, let me know, because sometimes your homework that you miss goes all the way back to April, like April 20th, April 21st. I don't when I check on Problem Addict to see whether or not you completed your homework, I don't go that far, because that would add another 30 minutes to my day, like where I have to go all the way back to April to check. So when you're done, all right, it's your responsibility to let me know that you completed. That way I can go look for your homework. Right? Tell me which days you've made up the homework for, and then I'll go check, and then I'll give you full credit. Okay? And then once you do that, I'll email you back. I'll say, hey, I checked it. I gave you full credit, and then I might even tell you what your new grade is. Okay. All right. Question 3 from yesterday's homework. Someone from a class emailed me, and the person said, "Mr. Ring, how come I put choice C and it was marked wrong? Like, because I said choice C in the video too, and I wasn't wrong, and you weren't wrong either. The problem was the website problematic. It forgot to mark that answer as correct. So it's the website itself. The website forgot to mark this correct. So as a result, there was no correct answer, meaning everyone got marked incorrect. So that's problem addict's problem. Okay, so you were right. I was right. Everyone was right except for the website. Okay, they didn't mark the answer correct. So okay, all right. That won't happen that often. I mean, it's very rare. When I was checking homework yesterday, I got a message, all right, from one of my students. He says, if you are, what did he say? He said, if you have really long questions for us to do, could you make the video shorter? And he's right. I think he's referring to the lesson on reflections. Remember all those triangles and quadrilaterals you guys have to like plot on the coordinate plane and then reflect and then write down the coordinates, right? So that was a lot. So I have a feeling that's what this person is referring to, and he has a case. He has a point. I think I'm very tempted to make the videos a little bit shorter. Now, right now, I think on average, roughly speaking, right now the videos are anything between 25 minutes, yeah, on average. And but that doesn't include the work that you guys have to put in. So from the beginning, the goal was to have like a full period worth of work, meaning like with the do now and the announcements, the lesson and the practice, including the time that you take when you pause the video to do the questions. I was hoping it would reach somewhere around 40 minutes. So I thought about it for a while yesterday, and if I were to, part of the problem is this. All right, I don't want to make the videos too long. Like because two problems arise when I do that. One is too much information gets packed into a video, and it's just very hard to digest. Okay, for you guys. And then the second thing is, if it's too long, I'm concerned that some of you are just gonna, tune me out. Okay, and that's not good. Okay, so on the other hand, if I make the videos too short, the problem is you guys already know. Like I've mentioned this from the beginning of the year. Like we have 42 minutes of class, right, per period when we were in school. And then back in the day, you guys used to line up outside, and then you come in. I would talk to you guys, and then you guys would come in and do the do now, and I'll check homework. And by the time we're done, like we have like 30 minutes for a lesson, which is very little. So if I make the video any shorter, like let's say less than 20 minutes, it's very hard to get anything done in less than 20 minutes. All right, so I'm trying to find this balance here. So I think if I cap the number up here at 20, I think you guys will learn and still be very engaged in the lesson, okay, without tuning me out. So that's what I'm gonna shoot for. Now, you can already see we're at 9-minute mark already. So that's the struggle. Okay, all right. Again, you can email me for your grades and missing assignments. Okay, all right, let's move on. All right, let's go real quick. So on the website, there is a what's on the website? On the website, I included a file, and in the file is this. It's a graphic organizer, because now the struggle is this. All right, back in the day when we were in the classroom, I can just give everyone a graphic organizer, and then you'll put all the information here, no problem. So, but nowadays it's a lot harder to give you guys a graphic organizer only because many of you don't have a printer. Okay, so if you go online, if you have a printer, I made a graphic organizer for you guys. You can print this out, all right, and then put it in your notebook somewhere. And if you don't have one, then I would suggest that you take about 5 minutes to write this down, like a very central place in your notebook. All right, so press pause and write this. So in other words, in the future, for the next 2 weeks, you can always refer to the same place whenever you do your homework. You know what I'm saying? So go ahead, take 5 minutes, copy this now. So this is a very large circle with 5 partitions. So 1, 2, 3, 4, 5. All right. If you can't draw a perfect circle, it's fine. If you want to draw a chart that looks more like this, I could live with that too. Like a something like a what, 2 by 5. So 2 columns, 5 rows. All right, but it has to be a very large graphic organizer. All right, as a matter of fact, as soon as I'm done showing you this, I'm gonna actually undo everything. So like something like this, like a two column by 5 row kind of thing, because we need 5 parts. Okay, so if you can't draw a circle, draw this right now, and in the meantime, I'm gonna undo all of this right now, so I don't have to erase it later. Okay, all right. So I'm assuming that you press pause and have finished this. So we're gonna start. So right off the top, we're gonna write this down. So let's see, let's pick a color. All right, triangles. So today we're gonna talk about triangles, all right, and how to find their area. Okay, so let's see. Now you need to write this here. Okay, so let me give you a few minutes, all right, to write this down. Okay, so press pause, write this again, write all this stuff in here. Okay, so press pause. Okay, all right, and we're back. So now area is half of base times height, and that's it. Or, all right, now see, I'm already out of space. Or it's base times height divided by 2. It's the same thing. Half of something is the same thing as divided by 2, right? So meaning in a triangle, because I can do this, let's use this. So in a triangle, you have a base here, and you have the height here. All right. Oh, that's not very good. Okay, let's try it again. And you have the height here. All right. So base times height divided by 2. Okay. So let me come back to this. All right. So now, on the surface, it seems straightforward enough, right? With any triangle, the lower side is the base, so base times height divided by 2. But before we even do any sort of mathematical, I don't know, maneuvering, the question is this. Depending on the triangle, right? I think it's very easy for all of us to identify the base, right? That's the base, that's the base, that's the base. But here's the question. Which one's the height here then? Can you answer that? Which one's the height? Like where's the height, right? And how do you define the word height, right? Yeah, this is the height, right? Now, you might say, okay, well, Mr. Ing, what, like, so you might say, Mr. Ing, why is Why is this not the height, right? And you be right. Good question. And my answer to you is this. A height, by definition, is a line that comes out of the base or is connected to the base. Once again, the height is a line that is connected to the base that forms, this is the most important part, that forms a right angle. One more time, okay? So I'll show you this. I'll go back and forth between these two shapes. Again, the height of a triangle is connected to the base at a 90-degree angle. Okay? So that's what a height is. So in other words, what do I show you? How do I show you? So in other words, let me use a different color. In other words, like this is not a height. Why? Because this doesn't, like this right here, nor this right here forms a right angle. It's not 90 degrees. That's why it's not a height. So one of the things I want you guys to understand is in geometry in particular, names like height and base are related to one another. So I'll give you an example. So just as, right, that you and your sister or brother, right, are related, we have a name for that. What do you call someone who's your brother and sister? Yeah, a sibling, right? So just as there's a name for that, so for example, let me ask you another question. So what do you call your uncle's child? So you have an uncle, right? And what do you call the person who's like their child? Yeah, cousin, right? So just as every human relationship has a name specifically for that relationship, in geometry, the parts only have the name on depending on the way they relate to one another. Okay, let me say it one more time. So again, in geometry, the names of the parts of a shape, okay, they have a very specific name, but like height and base, but only because of the way they are related to each other. So in other words, how did the word like height and base come about? It's because they are related. How are they related? It's because they form a right angle. By forming a right angle, this guy can be called a height, this guy can be called a base. Okay, all right. Hopefully, I said it enough times that you understand what I'm talking about. Okay, all right. Now, here clearly we have the base, right? Because it's right at the bottom, right? That's the base. Where would the height be? Yeah, it's right here. Okay, wow, that's a terrible line. Okay, so that's the height. Why? Okay, this is, yeah, let me do it again. So this is the base. And this would be the height. Why is this the height? Because this line by itself, right, forms a right angle with the base. So therefore, to the base, and in the triangle, this is the height. Okay, now, I saved the best for last, because look at this. Like, where's the height? Right, because you can't, oh, actually, one more thing about the height. The height, not only does it have to form a right angle with the base, this line here also has to be at the highest point of the triangle. So have you noticed, right? This point right here is the highest point of the triangle, right? And not only that, the line forms a 90-degree angle. Okay, let me see. I don't have the definition. Okay, all right. So likewise, right? This forms a 90-degree angle, and the height is also the highest point of the triangle. Look at the one in the middle. Same thing. right? You see the line here? Form a right angle like I just said. And this red line, the height, is also at the highest point of the triangle. So here's the question, right? Why is, first of all, why is this not a height? Yeah, neither one of these angles are a right angle, right? It's not a 90-degree angle, so that's not it. What else? What else? What about this one? Watch. This one, right? Forms a right angle here, right? How come this is not the height? Yeah, it's not the highest point. You guys see that, right? Where's the highest point of this obtuse triangle? It's right here. So now, having said that, knowing that's the highest point, what I'm gonna do is I'm gonna take a red line. Is that gonna be too thick? Yeah. And I draw this straight down. And I'm gonna take this, and I'm gonna go like that. So this is the height, because it forms a 90-degree angle, and it's at the highest point. All right, so this is, I know for some of you, this is very hard to fathom right now. Take my word for it. All right, so this is the base, right? I'll say it one more time. So this is the base. That's the height for two reasons. One, by extending, so it's okay. By the way, you can extend this, but this is not part of the base. The base is just this right here. Let me change the color again. This is the base right here. From here to here. This is the base. Okay? That's not the base. Okay? So, knowing that, you can still extend the line here. Okay? Because by extending the line, when you draw from the highest point down, you will do two things. One is you form a right angle, and then you're drawing from the highest point. Okay, so that's the height and that's the base. So now, if in case I didn't do a very good job of drawing, I actually took this. All right, so let's go over this real quick. Yeah, so in a right triangle like this guy here, right? This one's the base. That's the height. How do you know? It's the highest point. Forms a right angle. Okay, so the height is perfectly upright. Think like that. It's not like leaning toward one side. Okay. Second one, right? The height here in the second case, like this one here and this one here, they're coming from inside the triangle, right? Notice. Now, how do you notice the height again? Highest point, right angle, right? Highest point, right angle, highest point, right angle. Okay, and this last one, a height can be outside the triangle. So like this one, all right? This one's the base, 90 degrees, highest point. Okay, so, all right, now we don't have time. Yeah, I gotta stop in 2 minutes. So now, having said that, you know what, after this we'll stop, okay? So now let's read together. The triangle has I really like this color today. Okay, all right, the triangle has a horizontal base of 15 units, so the base is 15. Now here's what we're gonna do. We're gonna take advantage of this situation. We're gonna find the base and the height, and then we'll calculate the area. How about that? Okay, I think that will be a great end to the lesson. So the triangle has a horizontal base, so the base is 15, height is 7. Okay, so what they're saying is this. I'm gonna give you 3 blank triangles like this. All right, assuming that number 2 is what we're doing, right? Base of 15 and height of 7. Where would you label this? So in other words, where would the 15 go and where would the 7 go in this triangle? Okay, so now let's take a look. Base is this, right? So this is 15. Now where would the height be? I'll use a different color. Yep, right here. So this is 7. Okay. All right. What about this one? base is 15. Where would the height come from? Yep, right here. So this is the height. Why? Because this is the right angle, right? This wouldn't be, like the third side wouldn't be the height, right? Lastly, where's the base here? Yep, right here. Now, here's the question. Where is the height? Now, this is going to require a lot of skill that I'm not sure I have. All right, so here, right? So what you do is this. You draw the straight line down. Not that good, but it'll do. All right, and then I'll extend this little line here, right? So this is the base right here. The base stops right here. The base, and this would be the height. Now, I forgot to write the actual number. That's actually 7. So with that said, right, how do you find the area of a triangle? And then tomorrow I'm going to tell you where the triangle area formula comes from, okay? Area, what's area again? Look back at your graphic organizer. Okay, by the way, I got to tell you, so even at my age of 41, I still remember the first time I learned the formulas, and I still, like, I don't know how long ago now, 30 years ago, and I still can, like, say it, like, off the top of my head. So, you know, I think it's entirely possible for you to be able to do the same also. Okay, so how do you find the area? Base times height divided by 2, or base times height, right, times a half, right? Half of base times height. So either way is fine. So let's use this first one, okay? We'll switch around. So base times height, right? Just watch. 15 is base times the height divided by 2. What's 15 times 7? Let's see. 15 times 7. Let's see. I should probably do this in my head. Okay, 105. All right. Now, don't forget 105 is divided by 2. So what's 105 divided by 2? That is 52.5. Okay. Now, let's do it for this one, and then we'll stop for today. All right. Let's not go any longer. So we'll use the other one. So this one, let's use the other one. Let's use half of base. Base is 15, actually. 15 times 7. What's half of 15 times 7? 105. What's 1/2 times 105? All right, same answer. 52.5. Same answer. Okay, so today here's what we've done. Okay, if you wanna stop now, you can, but I'm gonna summarize real quick. Today what we talked about is I gave you the formula for the area of a triangle, right? And then I explained to you definitionally where does a base come from and where does a height come from and what's the definition of a height. And then lastly, right, we did some exercises that talked about if I were to give you 3 examples of 3 different types of triangles, could you identify the base and the height? And then we did 1 example together of using the formula. So tomorrow I'm going to explain to you where the formula came from, and then we'll get some practice in. Okay, so that's what we're gonna do tomorrow. So okay, all right, thanks for watching, and wow, 28 minutes. Okay, all right, have a good day and see you tomorrow. Bye. Okay, oh, there we go, there's the bell. All right, don't tell me you don't miss that bell.
OMG, that was so good.